Dr. J here. How's it? And let's get rocking and rolling. Okay, how's it? That's what I don't know, like the Brits and the British speaking, like the people who speak like British English, like those cats, they don't say like how's it going, they say how's it. So I said, how's it? All right. So let's rock and roll here. So this video is going to take you through the acceleration lab. So if you've been struggling to get that turned in, all right, this video will help you get across the finish line, okay? And if your words and what you turn in look a lot like my words and what I'm showing you here, that'll be okay at this point. All right, so here's your acceleration lab, okay? And here's your formatting note, right? So we've got to answer all these questions with complete sentences and organize our sections into one or more paragraphs, leave all bold section headers in place, and delete all the guiding questions with numbers before submitting. Okay, so we'll be doing all of that as we go, and we'll get rid of this formatting note up top. All right, so how is acceleration defined? So let's go ahead and get that written down. So in our notes, we have acceleration is defined as the change in velocity divided by the change in time. Okay, boom. And then and it's kind of, yeah, I guess this structure's a little, so velocity is defined as the change in position the change in time, or as the speed and direction of a moving object. Yep, period. Okay, you could go with either of those definitions and you'd be in good shape. All right, why is it important to understand velocity and acceleration in the real world? Okay, we need to understand velocity and acceleration while driving, okay? For instance, if we're driving at too great a velocity, it might be tough for us to decelerate. That's negative acceleration or stopping quickly enough to avoid colliding with another vehicle or obstacle. Okay? And then we just leave this fourth sentence alone. So let's go ahead and stitch all this into a paragraph. Gotta make sure we put a space there. Okay, that's one big issue people are having. Just gotta put a space in there and then delete that. Okay, and now that's a nice paragraph. We want to get rid of this little formatting note here. So formatting note gone. All right. This formatting note can also go, but we're going to leave the rest of it. Boom, boom, boom. Okay, so that didn't take really. Now that'll take. Okay, there we go. So results. Okay, so here I'm gonna actually steal somebody's data. Okay, so let me go steal some data from somebody who's completed all of this, and then I'll be right back. Okay, so now I've got a graph. I'm gonna blow that graph up. I'm gonna get rid of this. And then I'd like to get that whole graph on like the top page, but that's okay. We're just gonna leave it alone. Okay, and so let's answer these questions. According to your data, as height increases, how does velocity behave? Okay, so this is a very simple question to answer, right? As height increases, so as it goes from left to right, we can also see the velocity increases from bottom to top. So that's all we have to say. As height increases, velocity increases according to the data plotted in our graph. Okay, and the mathematical relationship. So I really just framed this sentence for you. Mathematically, height and velocity are related by the equation v equals 3.33 in this case. So I'm copying from the top of the graph, 3.33 times height to the 0.482. And I'll annotate to show you exactly what I'm seeing, okay? So I'm just copying this here to this little piece right there, okay? That little spot right there. And then what I'm gonna do is I'm going to go ahead and just erase anything that had to do with the original guiding question. And now I've got my sentence, okay? So now I'm in good shape. the data table from the bottom of my spreadsheet for day 2. Okay, so let me erase this little guiding question and go ahead and do that. So I'll pause the recording really quickly while I do so. Okay, so in this case, all right, in this case, according to my results, which process was more accurate, interpolation or extrapolation, and how do I know? So according to the data in the table above, interpolation was more accurate than extrapolation. Okay, I know this, I can make this conclusion because the percent difference for interpolation trials 4 and 5 was lower than the percent difference for extrapolation trial 6. Okay, and I should say the percents difference, okay, for interpolation, because there are 2% difference, 1% here, 1% there. Okay, so there we go. All right, now let me just get rid of the guiding question numbers. That's what we have to do here. It's kind of like two little, like one mini paragraph and then one standalone sentence for this section. So this is a nice section now. Okay, that's done. All right, in the discussion from what you currently understand about height and gravity, why do you think the golf ball's velocity increased as the height from which the ball dropped increased? Okay, so as the ball gained height, the ball gained additional time to accelerate. Therefore, balls dropped from higher heights at higher final velocities. Okay, and yeah, period. I'm just going to leave that alone. That's sufficient, even if it's not perfect grammatically. Okay, so reflecting on your data, were there any inconsistencies? How could such issues be avoided? Like, so the big issue, right? So collecting timing data by hand always, you know, incurs some error. So collecting additional data and being careful to avoid systematic errors like stopping the timer, stopping or starting the timer too quickly or slowly. Okay, on average, is important. Period. Okay. Your data may have allowed you to determine that interpolation or either was more accurate. Okay. So I'll just put the kind of the stock line here. So generally, and in accordance with the data above, interpolation is more accurate than extrapolation because interpolation occurs within the boundaries of known data, okay, to which, or from which predictive models have been constructed. Okay. Extrapolation requires prediction from outside the boundaries of known data. So unknown, unexpected deviations from known patterns, trends may occur. Okay. And I'm using pretty technical language here, all right? I'm writing as somebody who's already got his doctorate in science. So, you know, when you write this, you don't have to use exactly the words that I'm using. I'm giving you the best words I have, okay? I'm doing my best to write this as carefully and as accurately as possible. But write in your own words, you know, when you're going through this, write in your own words, or feel free to substitute words that you understand for words that I've used that you may not understand, or feel free to look up and Google any words that I'm using that may seem, you know, unfamiliar to you, right? Okay, that's how we learn. So this takes you through the written report for the acceleration lab. Please go ahead and get it turned in. And if you need to use words that are similar to the ones that I'm using, right? I understand, okay? But do your best to go ahead and get this turned in as quickly as possible if you've not already done so, all right? So as always, good luck, and may all the forces be with you.